Hello everyone. In this video we're going to be minimizing an expression in two variables. We have x squared plus y squared plus 4x minus 6y, and we're going to find the minimum value of this when x and y are real numbers. So x and y are real numbers, we're going to minimize this expression. Alright, I'll be presenting two methods. Let's start with the first one. The first method involves partial derivatives. So I'm going to write my expression as a function of two variables. F of x comma y is x squared plus y squared plus 4x minus 6y, and I'm trying to minimize f. To minimize f, I'm going to be looking at two things. First of all, the partial derivative of f with respect to x, that's the notation, but if you don't like that, we can also kind of write it as f sub x. F sub x is basically taking the partial derivative with respect to x, considering y as a constant. So y is considered a constant. The derivative of x squared is 2x. The derivative of y squared is 0 because y squared is a constant if y is a constant. The derivative of 4x is 4, and the derivative of 6y or minus 6y is also 0. Great. That is the first derivative. I'm going to set the first derivative, I mean the partial derivative with respect to x, to 0, and from here I'm getting an x value, so let me record that. X equals negative 2. I'll do the same thing for the y variable. The partial derivative of f with respect to y, which can be written as f sub y, is equal to, now x is considered a constant, y squared, the derivative of y squared is 2y. You're not multiplying by y prime because this is the partial derivative. And the derivative of 4x is 0 with respect to y, and then minus 6. And I'm going to set that equal to 0 as well. From here, I'm getting y equals 3. Normally, with these kinds of expressions, for example, if we had a term like xy, when we differentiate both sides or differentiate the function, we would be getting both x and y together in the same equation, and then we would set up a system and solve it. But this time, we're not getting that, and we're just getting to, an x value and a y value. So this is a point on this graph, which makes which gives us the minimum value. Okay, great. Since our function is not equal to any constant, basically we can replace x and y with anything, pretty much, right? So negative 2 comma 3 is basically a critical point, and there's only one critical point, so it must be the minimum, right? I mean, there's no other chance, obviously, but of course you can always check with the second partial derivatives and kind of check it out that way. I know some folks are not going to be happy because I didn't check that, but I don't want to keep the video too long because then other people will complain like you're dragging on too long. Anyways, let's proceed with these x and y values. My original function, so I'm going to be evaluating f of negative 2 comma 3, and that is going to be negative 2 squared plus y squared plus 4 times a negative 2, which is going to be a negative 8, minus 6 times 3, which is 18. So I'm getting from here 13 minus 26, and f of negative 2 comma 3 basically gives me negative 13 at the end. So this will be the the minimum value of my expression. All right, so that's going to be the answer. Let's go ahead and take a look at the second method. Now the second method, just can't decide. Okay, the second method is obviously a different method. And that is actually a simpler method. All right. So I'll take my expression x squared plus y squared plus 4x minus 6y. And then I'll be putting the x terms together and the y terms together. And then I will be completing the square. Now, how do you find what number to add? Well, you look at the coefficient of x. Half of 4 is 2. 2 squared is 4. So we're supposed to add 4 for the 4x. And for the negative 6y, I'm supposed to add 9 to both sides. But of course, you can't just add anything to an expression because it's not equal to something. So I added 13. I need to now subtract 13 to balance it out. Great. Now I can write my expression as x plus 2 quantity squared plus y minus 3 quantity squared minus 13. Remember, this is the expression I'm trying to minimize. I'm trying to find a minimum value. And as you know, if x and y are real numbers, x plus 2 quantity squared is always greater than or equal to 0. Y minus 3 quantity squared is always greater than or equal to 0. And their sum is also greater than or equal to 0. So you have something that has the 0 as a minimum value. So the minimum value is basically going to be determined by the constant here. So the minimum value of our function is going to be negative 13 as before. So the minimum value for our expression is going to be negative 13. And this brings us to the end of this video. Well, thank you for watching. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. I'll see you tomorrow with another video. Until then, be safe, take care, and bye-bye.